For quite a while, people have envisioned what life might be like in other universes. As a result of the James Webb Space Telescope, the most shocking telescope in existence, that question can at last be analyzed. While observing the nearest star system to us, Proxima Centauri, which is just 4 light-years away, researchers have noticed several remarkable idiosyncrasies from one of the planets in the system, Proxima b. These peculiarities, called counterfeit lights, have bewildered the best minds in the area of science. In any case, what are they? Do these lights suggest the presence of intelligent life? Join us as we examine the James Webb Space Telescope's upsetting discovery of city lights that could change everything. The principal life that we are currently aware of is on Earth. From the beginning of human advancement, people have questioned whether there is life elsewhere in the universe. To complete such an interstellar hunt, American cosmologists Jill Tarter and Tom Pearson launched the Search for Extraterrestrial Intelligence (SETI) project in 1984. The ultimate goal was to gather spaceborne radio transmissions. Radio waves can travel farther and are therefore more likely to be detected by the 42 radio telescopes that make up the extraordinary Allen Telescope Array in the California foothills. Anyway, before 30 years ago, no obvious extraterrestrial signals had been found. Following that, the James Webb Space Telescope's successful launch assisted the journey by enabling the observation of unnoticeable planets circling faraway stars. As the largest telescope on the planet, drifting around 1 million miles from Earth and equipped with highly sensitive instruments, it has the potential to reveal giant discoveries. Quite a while ago, there were no known planets outside our solar system. However, since then, more than 4,000 exoplanets have been found orbiting different stars. As illustrated by NASA, the universe could contain trillions of exoplanets. The earliest indications of something happening deep in space, beyond our solar system, might be seen as extraterrestrial vegetation. The Galileo space probe, on its course to Jupiter, turned its instruments back toward Earth and saw a clear sign of the presence of plants, recognizing the vegetation red edge, VRE, a biosignature, a blend of red and infrared light reflected by plants. For example, a planet like Earth, covered in wilderness, should have a strong signature easily detectable. The JWST will measure the VRE of faraway Earth-like planets in the habitable zone around stars, which could provide significant indications of something occurring on a deeper level in the exoplanet's atmosphere. When light crosses a planet-star system, the JWST may have the ability to recognize it as it enters its atmosphere. The missing frequencies would then be seen through spectroscopy, as particles and molecules in the atmosphere absorb specific frequencies, creating a characteristic fingerprint that the JWST can recognize. This technique might be used to determine the composition of the atmosphere and whether life is possible. Life could exist on Earth-sized planets with environments like our own, characterized by a mixture of oxygen, nitrogen, and carbon dioxide. By looking for elements that aren't ordinarily present, one might even detect intelligent life. For instance, chlorofluorocarbons, CFCs, made for use in refrigeration and cleaning products, would likely be detectable to extraterrestrials analyzing Earth's atmosphere from a distant location. If the JWST detects CFCs in planetary atmospheres, it could indicate the presence of life. However, life on exoplanets likely will not resemble life on Earth in any way. Sometimes, even ordinary living things, like extremophile species that can survive in conditions where other living things would die, can seem alien. This group of life forms, generally microorganisms, can endure extreme conditions, such as temperatures up to 250 degrees Fahrenheit or acidic environments with pH levels below 3. Since planets like Earth are more likely to support life than those with extreme temperatures or acidic conditions, it might be wise to start with those first. Prime candidates could have temperatures that allow liquid water to exist on their surfaces and orbit a stable star. Our Sun is a yellow G-type star. These stars are more extraordinary and usually have shorter lifespans. However, in our universe, the probability of finding planets orbiting red dwarf stars, which are more common, cooler, and dimmer than our Sun, is higher. This long lifespan allows the development of life and evolution to produce complex creatures. Around 40 light-years from Earth, the TRAPPIST-1 planetary system will be the subject of the JWST's first mission. It orbits a quiet red dwarf star with 7 Earth-sized rocky planets. 3 of these rocky planets, located in the so-called habitable zone, could have liquid water on their surfaces. Despite its smaller and colder mass compared to our Sun, the TRAPPIST-1 star emits light similar to Earth's, making it suitable for its planet's nearby orbits. The most obvious opportunity to observe city lights outside the nearby planetary system is Proxima Centauri, a red dwarf star that is 4.25 light-years from the Sun. Proxima is much dimmer than the Sun, so a planet would need to be much closer to it than Earth is to the Sun to support life based on liquid water. In August 2016, astronomers discovered a planet with 1.3 Earth masses in this habitable zone, a Goldilocks-like zone where the light force is ideal for melting water. Proxima B orbits Proxima Centauri. However, the fact that Proxima B is tidally locked makes it a potentially airless, dead planet. Since it orbits its red dwarf star only 4.6 million miles away, this close orbit exposes it to strong solar winds that could strip away its atmosphere. However, Proxima B gets enough light for temperatures and liquid water similar to those on Earth. Due to its proximity to the star, Proxima B is believed to be tidally locked, meaning it always shows the same side to the star, similar to how the Moon does relative to Earth. Proxima Centauri is about 18% the mass of the Sun and emits much less light than one might expect for a planet so close to the star, about 5% of the Sun's power. This could seem like a desolate, barren world, but liquid water could exist on Proxima B if the planet has an atmosphere to trap heat. Since the total energy reaching it from the star is only 65% of what Earth receives, the planet is not particularly conducive to life. It is likely tidally locked, meaning it constantly faces the same direction toward the star, creating a permanently hot side and a cold, dark side with extreme temperature variations. The JWST, specifically designed to observe infrared light, could potentially detect the infrared signature of Proxima B's atmosphere. If there is no atmosphere, Proxima B's day and night side temperatures will change more dramatically. Future space exploration and the search for life beyond Earth hold great promise. The James Webb Space Telescope may be the key to finding extraterrestrial life in the universe. As the JWST searches for exoplanets, it will ultimately help shape our understanding of other worlds and our own. The search for extraterrestrial life has taken a grand step forward with the capabilities of the James Webb Space Telescope. While we have only just begun to scratch the surface of what it can teach us about planets and distant star systems, the discoveries made so far offer tantalizing glimpses of what could be out there.